There we go. So good morning, everybody. Welcome to Big Data again. And today we're going to couple very short announcements, and then we're going to go over the material that you need for this week's lab today. Just kind of putting together some loose ends from material that we've seen so far. As usual, feel free to interrupt me with questions as you have them. Just unmute yourself and go ahead and ask. Or I have my chat window open. You can type it in and I'll get to it at a good time, or raise your hand. I'm going to share my screen here. And as I'm doing that, does anybody have any questions right now before we get started? Okay. So two quick announcement updates about office hours. I posted these surveys asking when people are available for office hours. Originally, I had them scheduled just immediately before and after class, but that's not good for a lot of people who are also in the data mining class or have other conflicts. And so those are no longer the office hours times. And instead, the standard office hours times will be 1 to 2 on Monday, Wednesday, and Friday. And again, if those times don't work for you for whatever reason, I'll also be available either before or after class. We have the 2 students who are going to be the mentors for this class, and the paperwork is almost finalized for them. So yeah, I apologize, it's taking a long time to get that all set up for you. But hopefully beginning of next week, that'll be, there'll be some additional times in the evenings that you'll be able to get help from them as well. But again, if anytime during the off hours you do have questions, feel free to post an issue to GitHub, and I will get your questions resolved as quickly as I can. So again, this is the standard office hours times, Monday, Wednesday, Friday, 1 to 2 p.m. Today, in addition to the normal time from 1 to 2 p.m., I'll also be having a special quiz review office hours starting at 2 p.m. And my guess is that that'll go until about 3 p.m. And the purpose, again, of this is that we have the quiz scheduled on Wednesday. And so this will be a chance to ask questions, or just to listen to other questions that people are asking specifically about that quiz material, and making sure you're prepared for that. Any questions about anything, any of those admin sort of points?
I have a question regarding office hours.
Sure.
So you said you were available to answer questions after class. Is there a time limit, like 1 hour or?
Yeah, good question. So generally, after class, I'll just be sticking around as long as people have questions to ask. So starting next week, things will all be in person. And so I'll just be in the classroom, and you can, if people have questions for an hour, assuming I don't have a pressing engagement, I will stick around for an hour. But if people don't have a lot of questions, then I'll just take off. And so you won't be able to like count on being able to leave and come back. It'll just be, I'll stick around as long as there's questions.
Okay, thank you.
Question about, will the review sessions be recorded? And the answer is no. I realize that not everybody will be able to make either the office hour sessions, or in particular the quiz session this afternoon. But in general, these review sessions will not be recorded, and that's because I want to make it as easy as possible for people to ask questions. Like, no pressure about feeling like maybe you have a stupid question and then it's going to be recorded for forever, and no pressure about like maybe being reluctant to share your screens or anything like that, because something sensitive might happen, and that'll be recorded. So for those sorts of reasons, the review sessions won't be recorded. Question in the chat about what classroom we'll be in next week, and the answer is Roberts North 12. So that's on the CMC campus where the cube is, just down in like that basement area. Good questions. Any other questions?
Will the in-person classes be recorded?
Yeah, the in-person classes will continue to be recorded and streamed over Zoom, and I will, in general, it's going to be a lot harder for me to interact with students over Zoom in the in-person sessions, so it'll be sort of like a read-only thing. I'm not going to be able to monitor the chat or anything like that in the Zoom sessions, but they will be recorded, so you'll be able to have access to them later if for whatever reason you can't attend the class live in person, or if you want to review the material later.
Thank you.
Great questions. Any other questions? Okay, one last quick announcement here up at the top. So on Monday, I made a bunch of announcements, but I have a little Friday update for us. And one of the main announcements that I made on Monday was just that if you recall last week, I gave you all a lab and a homework assignment. And the labs and homeworks are normally due on Sunday of the week that they're assigned. This past week, because it's the very first one, and to make sure that everybody has enough time to review whatever material you need to get caught up to speed in the class, there was no due date for the last homework assignment quiz. And so no matter when you turn it in, you will not get a late penalty. So just an update on how people are doing with that. So 18 students have completed the lab and submitted it. And if you're one of those students, your lab is graded. And 6 students missed points for various reasons. So you should check to see if you've missed points or not. And if you did miss points for whatever reason, then fix whatever the issue is and resubmit by sending me an email, and I'll regrade your lab. The homework assignment is something that not everybody needs to do. The lab, everybody does it. The homework, not everybody does it this week. And so still a handful of students not completed the homework. At this point, if you have not completed the lab and the homework, then you should consider yourself to be a little bit behind in this class. So it's not like insurmountable, it's not the end of the world, but you're a little bit behind, and so you should be feeling like a little bit of pressure about that to make sure to get on top of that. There is going to be a lab, so I've assigned a lab for this week, and it's posted down here. There's I consider it to be a short, easy lab. I think somebody who has fully understood all the material at this point, the lab should take about a half hour to complete. But this lab will be due on Sunday of this week. And again, if you do some collaboration with other students in the class, you can have an extension on that until Tuesday. But those deadlines are hard deadlines, and no extensions possible. Thomas, question.
Yeah, so you said that if we submitted the lab for week 0, then the grade should be on Sakai.
That's correct.
Okay, because I don't know, I'm not sure if I submitted it incorrectly, but I did submit it and I don't have the grade. So I was just wondering if I had a problem with my submission.
Let's see, after class, I can take a look and make sure that I've released the grades. It looks like there's a number of people posting that the grades are not posted. So maybe I forgot to press the release button so that you could all see access to it.
Okay, yeah, thank you.
I'll make sure to do that right after class. Good question. Okay, so today's material, we're just covering some loose ends that we've been exposed to so far in the things that we've been doing, but we'll kind of, I don't know, see them in a little bit more detail. Maybe Ty, remind us of some of the things that we've seen, some of the subtleties, and yeah, and this will prepare you for the lab. The two basic concepts we'll be talking about are parallel programming, and in particular with something called processes, and then some basic networking. So first, the parallel programming parts. So this is basically all of the hardest parts of an operating systems course compressed down into 5 minutes right here. And later on in this course, sort of the last week of the regular part of the semester, we'll be seeing this material in more detail, and there's going to be an assignment that will be related to this material that only the people not graduating this semester will be completing. So this is just sort of enough to get us started with so that we can complete some of the earlier assignments in this class, and then we'll be revisiting this material in more detail later. The main thing to take away from parallel programming at this point is that it is trivial to do in these POSIX compliant shells that we've been talking about. So bash, dash, sh. And I have trivial here in scare quotes. Trivial is in scare quotes because this is up to the sort of weird edge cases. And if you have a certain kind of mind, you're maybe filling in these punctuation marks with special words. But this is not intending to represent a curse word. These are like the actual causes of the edge cases in bash or the shell. All of these fun punctuation marks. And all of these punctuation marks appear in your quiz. And the main thing that the quiz is testing is these weird edge cases about the shell. If the shell is seeming weird to you and difficult, that's okay. It is weird and difficult, but I guarantee you it is 1,000 times easier than doing parallel programming outside of the shell, which we will see again at the end of the semester. So two basic techniques for parallel programming are threads versus processes. And again, this is going to be super, super high level. Threads are what we call lightweight. So there's minimal overhead. And by overhead, I mean the amount of memory that the threads use and CPU resources, that kind of thing. And one of the reasons for that is all of the threads share the same memory. And so communication is easy between different parallel processing environments that use threads. Downside of threads, they're slightly less safe, and a bug in one thread will cause the behavior of your entire program to crash. And starting, not next week, but maybe the end of next week, definitely 2 weeks from now, we're going to start talking about database systems. And we're going to see that there's sort of two popular open source database systems, MySQL and Postgres. If you took the Foundations of Data Science class, CS 36, then you might not have heard the word MySQL actually like expressed, but the R SQL stuff that you were doing was using MySQL as the backend. And MySQL does all of its parallel programming with threads. But MySQL is also infamous for having all sorts of bugs that corrupt your data. And one of those reasons are because they use threads, and threads are just really hard to work with. Another thing about threads is that while you can use them in Python, you can't actually do parallel programming with threads in Python. Python has something called the global interpreter lock. And this is something that Guido van Rossum has been very opinionated about, saying he wants the global interpreter lock to stay around, meaning that Python will never be able to do parallel processing. Until, I guess about 2 years ago now, Guido stepped down as the benevolent dictator for life of Python. And so now there's been a lot of proposals on removing the GIL, and it wouldn't surprise me if 5 years from now that's been removed and parallel programming in Python is possible. But at this point, parallel programming inside of Python is not possible. And so we're going to be focusing on the idea of processes. And that's also, again, why we're using the shell for our parallel programming in this class, because we're using Python, and this is the only way to do, processes are the only way to do parallel programming in Python. Disadvantages of processes are they're what we'd call heavyweight. So there's about 10 megabytes of unavoidable overhead per process in the system kernel. The kernel being the actual like main part of the operating system that does all the hard parts. Technically, for some processes, this can be a little bit smaller. It can go down into the kilobytes range, but for any interesting thing, it's going to be on the order of about 10 megabytes. And in particular for Postgres, this database that we'll be using, it is exactly 10 megabytes. And this is important because if we had, say, 100 people who are trying to do different tasks on our Postgres database, they're all needing a different process. And so that's just 1 gigabyte of RAM, 10 megabytes times 100 people, 1 gigabyte. That is just totally overhead, and we can't take advantage of it. So because of this like process thread split between MySQL and Postgres, back in the day, MySQL was more popular using threads, trading off less safety for better performance. Computers now are fast though, so processes are sort of the direction that people are going in with parallel processing in general because they're safer. And the fact that they use more memory, well, memory is cheap. It's $100 to get however many gigabytes, and so everybody uses processes these days that are starting new projects. Yeah, you might have heard of forking before, or if you haven't, this is the basic idea behind multiprocessing with processes. And so that's threads versus processes, high-level overview. If the details don't make sense, again, that's okay at this point, but I'll be using those terms throughout the rest of the semester. And the main takeaway, though, at this point, though, is going to be that just programming with threads or processes, doesn't matter which one, is hard, like extremely hard. Like this is the fundamental challenge of computer science, but processes is easier than threads. There's lots of types of bugs that come up specifically due to this, this parallel programming environments. And things are what are called non-deterministic. So every time you run your code, you'll get different results. And this leads to something called Heisenbugs. There's two particularly famous examples of these Heisenbugs right here. I'm not going to go through them in class, but these are things that every educated data scientist / computer scientist knows about. And so strongly recommend you read these two links on your own time. Yeah, let's switch over and talk a little bit more technically about these threads versus processes now in the shell, and see a little bit more detail how they work. So I have two terminal windows open here, and you can see that I'm currently logged into my laptop system on both of them. And so I'm going to Control-R SSH to bring up my previously used SSH command to log in to the Lambda server here. And then I'll do it a different way up top, just copying and pasting like that. And logged in on the same machine 2 different times. In the first lab, we saw there was this PS command that shows what are the processes associated with your current environment, your current login, your current shell, your current terminal session. And these two sessions are totally disjoint from each other. So I type PS up at the top, PS down at the bottom. You see that the results look similar. They both have one of these bash and PS commands running, one of these bash and PS commands running. But then this PID over here, this process ID, you can see is different for both of them, 906, 970, 804, 1371. And so these are 2 different commands, 2 different processes that are running in the top and the bottom down here. And if up top here, say I typed Python like this, now Python is another process that is running. It's running up here. But if I type PS down here, we can see that it is not running down here. One of the common commands that I use when I'm manipulating processes is the ps-ef command. This will print lots and lots of information. I'll go ahead and press enter down here, and we can see that it prints out information about all of the processes that are currently running on the Lambda server. If I want to get just my processes, we'll grep that into user test like this. And here's all of the user test processes, which you can see there's quite a bit running right now. This is due to Docker. Docker's running, and Docker runs a lot of processes in order to manage things. I'm going to do one more pipe, though, to whoops, not to Python, but grep Python. And you can see that there are some Pythons running down here, in particular this one right here, which is going to correspond to the Python that I ran up here. I can see that because up on the top, I'm going to press Control-Z. So that was CTRL-Z, not C or not D. Control-C sends something to the background, sends process to the background. And then if I want to verify that the process is running, PS again, and now we can see that this Python up here is running. If I want to get back to the process, FG, reopen it, and I'm back in Python. Again, I can use the prompt, the shape of the prompt, to determine whether I'm in a shell session or in a Python session. Python always uses these triple greater than signs. The terminal conventionally uses the $sign for ordinary users logged in, and the hashtag for super users or root when they're logged in. If you're on a Mac, on your own personal computer, I think the default is %. And now let's see, let's get out of Python up there. So here, when I did Python, and let's try a different command for a second. Let's do the sleep command down here, sleep1. The sleep command is going to just make your program, make your shell session sleep for however many seconds you have typed over here to the right. So sleep1 makes it sleep for 1 second. Sleep10 will make it sleep for 10 seconds. And so this is never something that you'd necessarily want to be typing into the terminal window, except as a demo like this, but mostly something that gets used in shell scripts when you just need to pause for something to be downloaded. And but what I'm going to use this as a demo for is to demonstrate what's called forking. So demonstrate forking in the shell. And the again, the forking creates a new process and will send it to the background. So it's basically like automatically pressing Control-Z for you. And the way you do this is you put the ampersand at the end of the line, a single ampersand like this. And this says, run the program, but send it to the background. If I type PS, you can see that sleep is still running right here, but it's in the background. And if I wait a little bit, there we go, sleep has terminated. It is no longer in the list of processes from this session. So there's that ampersand over here is sending it to the background. The way this is going to come up in the short term for this class is in your MapReduce homework assignment down here at the bottom. The way that you'll make all your code running efficiently in the background is you will be using the ampersand sign to cause your code to generate many different processes, and they'll all run in parallel, and so things will finish much faster. Okay, that is processes without the intersection with Docker. What we're going to talk about next is processes intersecting with Docker, how those two things relate to each other. But before we do that, I'll pause to see if there's any questions. Okay, then let's go ahead and move on to how processes and Docker interact. So Docker, we said, is supposed to be, Docker is supposed to be like a virtual machine. So it's a system that lets us run sort of these pretend computers in pretend environments and give us some amount of isolation between these different systems. And last time we saw a lot of different Docker commands for different tasks. I'm going to cd into our project 143/week1 folder. And last week we had this Docker example, sorry, not last week, last class session, Docker example, where we had this, this Docker file. And so let's just open up the Docker file like this. And this was the name of the image that we were, that our Docker was being based on. Our Docker container is based on this image right here. And then we're automatically running these commands down here so that we don't have to do it manually. And this command down here is just installing Python for us. So if I :q, exit out of vim, if I do the docker build dot, again, when I do Docker build, I specify a folder over here, and dot is a special folder that refers to your current folder. This is my current folder, contains the Docker file we were just looking at. And yeah, so that's what I built, is the Docker file that we were just looking at. This right here is the hash that is going to be sort of the most important piece, or the most important result of running Docker build. And I need to know this hash in order to actually start my Docker container. So I'll do, and let's go ahead and do it down here in the bottom. Let's reset my terminal. I'm doing it in the bottom just to demonstrate that it doesn't need to be in the same terminal session, don't need to be in the same folder. And I want to do a docker run -it, and then put this hash value right here, and then let's run the bash program. I'm now a root super user. I know it's root because it's telling me I'm root right here, and it's using the hashtag as the prompt instead of the $. And now I can type in various commands like Python, like that. And now Python is running down here. Question, Dustin?
Yeah, so if there's like multiple Docker files in that Docker example folder, and you just wanted to build one and not all of them at the same time, what would it be? Docker build and then specify the image that you wanted to create?
Yeah, this is a great question. So the question is basically about the structure of this Docker file and building multiple things at once. And there's a lot of things that I like about Docker, but this is one of the things that I absolutely despise about Docker. Unix and Linux, POSIX, all of these Unixes, they have this underlying philosophy that files are the most important thing. So in Unix, the philosophy is, everything either is or should be a file. It's so files are a universal interface, and we shouldn't actually care about the names of files. You should never care about the name, only the contents of a file. One of the, we have the caveat tasks in this class that have some extra readings. One of them is to a book by ESR, about the Unix philosophy, and it's got lots of examples about why this is the case. But basically, everything just works together really nicely and magically. You can pipe things together nicely. I don't know, everything's just super nice if you obey this rule right here. But for whatever reason, Docker decided to break this rule, and Docker files must be named exactly Docker file. And in Docker, it's the directory that is the fundamental thing. In Docker, the directory, which is another synonym for folder, is sort of the fundamental unit. And so this means that, as an example, it's never possible to have multiple Docker files in the same folder. and you can't pipe things into Docker build. You can't pipe the output from Docker build to somewhere else. So Docker does not work well with things. You just have to have a folder with the word Docker file inside of it. And so yeah, specifically about your question, if there's multiple Docker files or you want to build multiple things inside of a folder, the question just, the way Docker works, it doesn't actually make sense that way, which is unfortunate. It's the main thing that I hate about Docker, but it is what it is. Gotta live with it. Good question. Any other questions at this point?
Professor?
No?
Yeah, I was just wondering. So basically, we can have multiple Docker files, but it just have to be different directories. That's what the whatever this says, like in contrast, right?
If you have multiple projects, or even one project that uses multiple Docker containers, you must have them in different folders and different Docker files.
Okay, thank you.
Let's see, maybe related to that. So here we were talking about like how these hashes are the most important output of the Docker file. It is possible to specify a name for your Docker output. So if we did Docker build, pressing the up arrow and down arrows until I get back to Docker build. If I do Docker build -t class example like this, -t, for whatever reason, is the letter that they chose for how you name an image. So now instead of using this hash right here, I can name the image as class example. And now in order to run it, let's exit out of the Docker container down here. I can type in class example like that, and it starts up Docker again, and we know it's the same one because Python works. But it's incredibly frustrating that, well, it's incredibly frustrating that they chose -t as like naming something. There's no sense in which T should be the right abbreviation here. And it's incredibly frustrating that I would really like to be able to have this name somehow be related to the Docker file, but there's no way to do that. Yeah, in the lab, I think there'll be instructions that ask you to put a -t somewhere, and that's the reason it's doing that. But what we were talking about, to our next step of what we're doing, is how does processes relate to Docker and this containerization. Right now in the bottom terminal, I'm inside of the Docker container. Again, I know I'm in the Docker container because I ran the Docker run command. And so all of this is inside the Docker container. And up here, this is outside the Docker container. This is just on the, sometimes we'll say it's on the bare metal or on the naked server, not in the container. And I want to do that ps-ef pipe grep username command. That this is going to give me all of the, oops, not username. Who am I? I am user test, not username. So let's pipe grep user test. And this is going to give me all of the processes that are currently running by my user test user. And so I'm going to do, see if there's any Python processes running. Pipe Python, did it again, pipe grep Python. And so there are currently these 3 processes running down here. And now down here on the bottom, I'm going to start a new Python. Let's do who am I? I am root. I'm not Groot, I am root. Type Python, and now Python is currently running down here. We know Python is running because we can see that Python is in fact running. Up here at the top, I'm going to press the up arrow, and here we re-see this same exact command that I ran before. Notice that there was no Python running up here, or there were some Pythons, but they were different Pythons. Now, this Python has been added. This Python did not exist up here. This Python is under the user test. In the Lambda server, on the bare metal of the machine, this Python is running as the user test. Down here, this Python is running as the user root on this sort of weird virtual machine environment. Press Control D down here, stopping this Python process. Up here, up arrow, rerun it. You can see that the Python process did in fact stop. It does not exist anymore. Down here, up arrow, run it. It is in fact running down here. It is running as the user root. We know it's the user root because when I ask, who am I? It tells me I'm the user root. Run Python. Up here, there's user test. So these Python, or sorry, these Docker containers, they sort of give us a pretend environment where it seems like from inside of here, if you do nothing strange, nothing weird, then you're going to be isolated from the other things. That looks like I'm in a root folder over here, and that if I make some new files, touch new file, that does not appear on the root folder of the Lambda server. I have root, so I have special root permissions on this sort of weird thing that's a virtual machine that's not a virtual machine. But the reason that it's not a virtual machine is because the processes actually appear on the Lambda server as if they're being run by the original user. And those processes can interact with each other. And it's also possible to do what's called jailbreaking, jailbreak the container environment to get out of here and then mess up somebody's system. Joey, go ahead.
I'm curious if we're able to create multiple containers off of the same image. So say we have a Docker file for a particular image, are we able to create multiple containers off of that image at the same time?
Yeah, this is a great question. So up here, I'm going to run Docker PS at the top. And so there you can see there's these three Docker containers that are running, which I'll talk a little bit more about very end of class. But right here, this class example container is what is currently running down here on the bottom. I'm going to create a new class example container that's running, but I don't want to do it up here in this environment. Instead, I'm going to open up a new terminal, Control R, SSH, that, and log in. And now let's do rerun the Docker run dash IT, and we call that class underscore example, and we want it to run bash. So now we have two containers, one here on this rightmost terminal, another here on this bottom leftmost terminal. Both of these are running this class example container right here. And then up here in this top left terminal, it's on the bare metal, not inside of a Docker container, on the Lambda server directly. And now when I run the Docker PS command, and let me reshuffle around my systems again. So it's up here at the top, Docker PS. This is the bare metal up at the top. These two terminals down here, both inside of containers. And up at the top, we can see there are two containers running class image like this, and they just happen to have different container IDs. If down here, I'm in the, so pwd ls, down here, pwd ls, you can see that the contents of these two containers are different. I created this new file in the bottom container. That does not affect the top container in any way. So just like when I exit a container and rerun the container, it's not going to have any effects exiting and coming back in. Causes all the contents of a container to reset to what the default contents defined in the image are. And the containers basically have no way of interacting with each other. Or they're supposed to have no way of interacting with each other without doing crazy hacks behind the scenes, going under the hood. They don't interact with each other. Maybe another way to see how they don't interact with each other, let's do a Python, run a Python down here. We saw that up here, I'm going to press Control R, Python, to get back my ps-ef pipe grep user test Python command up here. Here's these 4 Python commands. In particular, this one up here on the top corresponds to this Python down here. exit. Let's just verify that those correspond to each other. The line went away. Now there's only 3 down here. There used to be 4. Come back down here, up arrow, rerun Python. Come back over here, up arrow, rerun that command. Now there's 4 things. So this line right here definitely belongs to this Python process right here that's running. But now I'm going to copy and paste this thing right here down into this terminal right here. And you can see that we get no results. That once you're inside of a container, you can't access the processes from another container. If you're outside of the container, you can access their processes. So if you're inside of the container, then it's like these are 2 separate machines and they have no way of interacting with each other. If you're outside of the container, then it's possible to make them interact with each other. In particular, I could do something like kill you, and from the Lambda server outside of these machines, I was able to kill this this process right here. So there's communication from Lambda into the process, or sorry, into the Docker containers. No communication from one Docker container into another Docker container. Great question. Any other questions at this point?
Just kind of a follow-up question on my previous question. How would you name the particular container that you're creating off of the particular image?
So we do Docker PS. Here we can see that we have this image has these names. Every container is assigned a hash, whether it's named or not named. Containers also have, so the containers have both a hash and they have a name. This rightmost column here has these 2 names over here, which are assigned to these 2 containers. These names are, when we do the Docker run command, so I'm gonna exit out of this container up here, Docker run, and then I'm going to do -- help to see all the options for Docker run. And then I'm gonna take those, I'm too lazy, I can't read through all that stuff, so I'm gonna type that to grep for the word name to see what are the commands that might be related to naming things that have the word name inside of it. And hey, over here there's a -- name. So for whatever reason, when we're doing the Docker run command, if I want to name the container, then it's Docker run --name -it, the name of the image class _ example, then the command that I want to run. So, oops. Oh, --name, then the name that I want to give it. Since Joey asked the question, Joey container like this, then the -it, then class example bash. Now I'm inside this container down here. Up here on the top, Control-C to get a new line, Docker PS to see it. And so container ID, this one right here, the names, that one is named Joey container. So it's Docker has, all the parameters are very confusingly named for Docker. It's totally inconsistent. Doesn't match with any of the conventions normally used on the Unix terminal. And so for that reason, I hate it out of principle. But everybody uses Docker because under the hood, the actual meat of the engineering is all fantastic. Technically, the reason why the Docker run command does not use the -t flag is because the -t flag was already taken for this, the T here standing for the TTY, that it's interactive in the terminal, and so they couldn't use the -t flag again. Adi, question?
Yeah, so the -t, just to clarify, the -t flag is used for to name the image.
Exactly. So
Okay.
up here, when I ran the build command, I pressed Control-R right now just to get back to the build command. You can see it's Docker build -t class example. The build command names the image. The image is like the prototype for the container. The container is the actual computer that's being run. The image is like, here's the initial install of what goes onto the container. And the -t on the build names the image. the dash name on the run names the container.
Oh, okay, that makes sense.
Great questions. Any other questions so far? Okay. And again, the lab for this week is really just designed to get you some familiarity with running these commands, and has a preset set of commands that you go through and run, just to make sure that everything is sort of working. You don't have to do anything like creative, like create a new command for yourself. It's really just copy and paste and make sure you get the right output. So that's our discussion of processes, and that, again, takeaway is processes, parallel programming is hard, and the terminal makes it a little bit easier, and that the processes cannot talk to each other in the different containers. Except, the exception, always an exception, except they can talk to each other the same way any computer anywhere in the world can talk to each other, through sort of normal networking, like the internet, or Ethernet, or Wi-Fi, or Bluetooth, or any of those things. And so we're going to do a real quick overview of networking. Starting next week, we're going to be setting up some virtual networks that contain multiple Docker images talking to each other over the network. But this is just sort of like the introduction, get you a little bit used to some of the basic terms, and again, making sure you have a sane working environment. So the main important term is the Internet Protocol IP addresses. Basically, every device on the internet has a unique, what's called an IP version 4 address. If you've ever seen a set of numbers that look like this, like the Lambda server's numbers, that's an IP version 4 address. And we're slowly moving over to the IP version 6 standard, which has things that look like this. The Lambda server does have an IP version 6 address, but I have no idea what it is. And it's also from the school's network. You can't connect to it over IP version 6. I can connect to it at home because I have IP version 6, but your networks do not here. And then IP version 4, we'll be seeing this address later on. This is a special address called the loopback address that takes you directly to your own machine. So no matter where you are on the internet, no matter what your IP address is, this always refers to your own personal computer that you're currently connected on. Many machines on the internet offer many different services that they're running, and we use what's called a TCP port number to identify what service you're running. These numbers go anywhere from 1 up to 65,000. So you can have, at a maximum, 65,000 different servers that you're running on one machine. Most of these ports have standard things that are associated with them. So the one that you've most commonly been using in your life is port 80, which is HTTP, and 443, which is HTTPS, the two main ports, or the two main protocols for the internet. Normally, SSH, so the tool that we're using to connect to the Lambda server, normally that is on port 22, but the IT folk at CMC have changed the Lambda server's SSH port to 5055, just in order to make it a little bit more secure. I would say, so literally about once every 5 seconds, somebody from the random place in the internet in the world connects to the Lambda server on port 22 and attempts to run guess usernames and passwords on the server and try to log in and do malicious things for malicious purposes. And to make the Lambda server a little bit more secure, they changed the port number because now nobody connects to it except the people who are supposed to. On the another thing related to ports is that any port with a port number less than 1024, any port number with a port number less than 2 to the 10th, is reserved for only root, only the admin user is allowed to create services that listen on that port. Anybody else is allowed to create services that listen on ports above 1024. And so there's going to be some instructions in the lab that'll ask you to select a random port number to do certain things, and you'll have to just pick a number above 1024. Any questions on any of that before we connect that to Docker? Okay, so I mentioned a little bit earlier before, I'm going to go ahead and exit out of these extra terminals that we don't need. And let's go ahead and reset our screen up here. If I run Docker PS like this, then there are these three Docker containers that are already running on the user test account. And these three Docker containers are sort of a minimum viable set of Docker containers for running this web page server search engine that we talked about the first day of class. And again, as we go throughout this class, we'll be talking about more and more features about this search engine, how search engines work, how you build them, until eventually you're bringing up and down your own full search engine and loading it with data, petabytes of data to do whatever you want with. But at this point, the first thing that we have to do is just learn how do you connect to this search engine. And I'm going to switch back over here to Firefox. And let's open up a new tab. And I'm going to type 127.0.0.1 and then a :8080. The thing to the left of the colon, that is the IP address that I'm connecting to. So 127.0.0.1 means my own personal computer, the laptop that I'm currently running Zoom from. And then this 8080 over here is a port number. 8080 is a very common port number for HTTP because you remember that HTTP by default uses port 80, but non-root users cannot create a port less than 1024. And so 8080 reminds us of HTTP, but it's big enough to that any user can create it. So this is the port that I'm going to connect to for accessing the search engine. I'm going to press enter over here, and we'll get this unable to connect error message. Firefox can't establish a connection to the server. In order to fix this problem, I have to do what's called port forwarding. And in port forwarding, I'm going to type exit down here. Currently logged into the Lambda server. I'm exiting to go back to my laptop. And I'm going to expose a port that is currently open on the Lambda server to my laptop. And I have to do this for various firewall reasons about that the IT people have put around the Lambda server. And I'm just going to give you the magical incantation here right now, and then we'll talk about why this is the right incantation. So it's -L 8080 : localhost : 5000. I'm going to hit enter, type in my password, and I'm back in the Lambda server just like if I logged into the Lambda server with only the standard SSH commands right here. Again, the -L stands for what's called port forwarding. The L is confusingly named, like YL, and this is because it's a special type of port forwarding called local. So that's what the L stands for. This 8080 over here is the port number on my machine that I want to be able to access. This is the name of my machine where I want the forwarding to happen at. This 5000 is the port on the remote machine that I'm connecting to. This here is the remote machine that I'm connecting to, the particular port that we're connecting to. And so whatever is on 5000, port 5000 on this IP address, I can reference by going to localhost 8080. Come back up here. Localhost is a synonym for 127.0.0.1. I hit enter. Hopefully things work. Yep, there it goes. Let's zoom it out a little bit. So this is 127.0.0.1 that I'm connected to. I could also do localhost : 8080, and it would work just the same. Things will be a little bit slow because it's not fully set up for speed right now, just to make sure it doesn't conflict with any of the things that you all are doing on the Lambda server. But you can do whatever search terms you want, and you don't have to play around with it. The important thing is just that you get the port forwarding to work, and then you're done. And that'll be the first part of the lab. There's one last thing before I take questions, is that, so this is how you do port forwarding from a Unix terminal. So whether if you're currently on Linux or currently on Mac, typing in your SSH commands like this is how you just modify your SSH command. If you're on a Windows machine and you're using PuTTY, you're not typing in SSH commands, and so instead there's a checkbox somewhere that talks about local port forwarding, and it has these particular numbers, or it has locations for you to type in this information. In the lab, so here's a reference that talks in detail about port forwarding, and then down here there's instructions particular for PuTTY on how to do the port forwarding that you can reference to make sure that that works for you. There's a question in the chat about, is there ever a case when localhost is not equal to 127.0.0.1? And the answer is that it's possible to make that happen. Localhost, technically what's happening with localhost is there's a file called vim/etc/hosts on a Linux system. I open that up, and these are all of the mappings that anytime it sees this, it automatically will replace it with this. In this case, I'm currently logged into the Lambda server, so that's why it has Lambda server as a special thing here as 127.0.0.1. I'm gonna quit out of this and quit out of the Lambda server here and open up the /etc/hosts file on my personal laptop. This file is often referred to as just the hosts file. It's called the hosts file. This folder right here is pronounced etc, not etc, not etc, etc. That's one of the, again, the shibboleths that you know if somebody's been using Linux their whole life or not, been using Unix their whole life or not. They're like, if they've drank the Kool-Aid because they pronounce it the most efficient way possible, etc, not the way that Muggles pronounce it, like etc. Too many syllables there. And again, this is called the hosts file, not the /etc/hosts file, just the hosts file. And if I open that up here on my machine, you can see that I have a very extensive hosts file because there are a lot of bad sites on the internet. What's on my screen now is particularly bad sites, but even things like Google Ads, Google Analytics. I don't want my computer connecting to all of these ridiculous websites and slowing down my internet connection. And so I have all of these like URLs mapped to localhost, so it doesn't connect anywhere. Actually, I forgot that for CS40, I took away these lines here so that I could demo Google Analytics in class. I need to add those back in and speed up my internet and stop sending Google my private data. But there's like good host files like that that you can download from the internet, and all the cool Linux users do that and get faster internet connections. Sort of like an ad block that works not just for your browser, but for all possible programs. Kieran, you have a question?
I was just wondering if you could maybe do like a PuTTY example, because I don't know if the website that you linked as like a tutorial for PuTTY is still up.
This one here should have the tutorial for PuTTY. If you can't get PuTTY working, we'll have to do one-on-one sharing your screen. But since I don't have Windows, I can't bring something up on my computer. But I have to do that after class.
Yeah, because whenever I go to the URL, it says the resource you're looking for has been removed, had its name changed, or is temporarily unavailable.
Let's see. So anytime you visit a URL and the URL doesn't work, the internet has been mean to you and taken away a particular resource. There's this really cool website, archive.org, which has an archive of not the entire internet, but the entire good part of the internet. And you can copy and paste that URL into the Wayback Machine here and hit enter. and it will take us to snapshots that it's made of this, this URL in the past. And so you can see different times that the snapshots have been taken. Let's try March 1st at 1546. And then you can get access to old web content that way. This data set that archive.org uses is actually one of the data sets that we'll be using to dump information into our search engine. That Archive has a really robust crawling system that they crawl the internet, and so we can just, we don't have to write our own web crawlers. We can use their web crawler and search their database. Just have, so again, yeah, the times on this class are super awkward, that it starts at exactly at 11, ends at 12:05. I just want to highlight this. Yeah, so this first part of the lab is just making sure that you can SSH in. The second part of the lab, there's some instructions right here that just ask you to copy and paste some Docker commands and Docker files, get a basic web page running. It's not specific to the class at all. This is just like a random outside tutorial. And so there will be some things in here that I haven't covered in class. There'll be some things that you have to modify very, very slightly. And that's intentional, just to get you practice with following outside tutorials that aren't geared to your specific exact environment. But both portions of the lab together should go relatively quickly. And the only thing that you have to submit once you've completed them is just submit a sentence, "I've completed the lab" to Sky, and I will believe you, and you'll get the credit for the lab. Any questions about anything? Okay, then that will be our official stop for class today. Stick around to answer questions that people have. Right now, one-on-one, I'll be back online for office hours starting at 1, and we'll have the review session specific towards the quiz starting at 2. Yeah, I will see you all either then or next week, and hopefully in person. Adams 12, or not Adams 12, Roberts North 12, and it'll be good to actually see you all.
Thanks, Mike.